All right, so welcome to our next interview with Night Hacking at JFocus. I'm Stephen Chin, and with me I have Jim Manicode, and we are going to teach you how to secure your Java programming in 10 minutes. Disclaimer, this is not actually a security course, and any damage that results is from the practices we expound here, we're not liable for.
We'll at least get the conversation started, Steve.
Yeah,
How's that?
yeah, there we go. Okay, Jim, so tell us a little bit about what you do and who you are, and then we'll go through some of your security.
Sure. My name's Jim Manico. I'm one of the board members of the OWASP Foundation. I'm an independent secure coding trainer. I teach developers around secure software design and development. And I'm from Hawaii. Aloha, everyone. Hello to my friends out there in the islands.
You seem slightly underdressed for the Stockholm wintry weather here.
Yeah, I mean, not so much into the thick jackets, gloves, or hats. I'm more into like the Hawaiian shirts and shorts and sandals kind of thing.
Yeah.
That's my preference.
So you walk around town like this?
No, actually, this is overdressed for Hawaii. I tend to have shorts, sandals, and yeah, that's how I tend to roll.
Nice. Okay, so you said that you had 10 different secure practices you wanted to cover.
Yeah, one of the projects I work with at OWASP, and as a quick note, even though I'm a board member of OWASP, I'm going to talk about an OWASP project. OWASP is a vendor-neutral, nonprofit organization. They don't endorse any of my commercial activities or anyone's commercial activities. It's just a nonprofit organization that I work with. So, you know, my commercial activities and my OWASP nonprofit activities, I firewall them as much as possible to try to remain ethical. So,
cool.
That aside, I'm going to talk about an OWASP project called the OWASP Top 10 Proactive Controls. It's just a project I'm working on as an awareness document to teach devs about secure coding. So the first of 10. Are you ready for 1 of 10?
Wait. Okay, I'm ready.
Yes. I think and a lot of these are boring, but the work of security is not when you do hacking. No offense to night hacking, that's a different kind of hacking. The real work in security is when you're designing secure software and writing lines of code using proper security controls or defenses. That's where the work is done. And it's minutia, it's detail, it's not even glorious. It's, you know, when you're coding and sweating and getting stuff done, that's where the security is done. And we're going through a culture change now where years ago it wasn't that important. Today, it's never been more important. So number 1, secure architecture and design. You know, we want to plan the dive and dive the plan, regardless of whether we're doing agile or DevOps or traditional waterfall. We're all going to have some kind of process to think about how we're going to build software before we build it. And there's
do you ever get any pushback from the agile community about security practices or how you integrate it with their more fluid development style?
No, I don't think so, because keep in mind, when you talk about agile is not about quickly writing crappy software. Agile is about iterative approaches, iterative high-quality software release. So it's not like we're just slapping stuff together. A true agile team has a disciplined and well-thought-out architecture, really elite processes and redundancy in programming, and they have baked into that agile process the ability to quickly release high-quality software. Now, a lot of agile teams, they take the good of agile, let's let my manager change requirements, low documentation. They take the fun parts of agile and embrace that, but the disciplined part of agile, many people throw away. So if you're throwing away the disciplined part of agile, you know what you are? You are not agile. So we need that discipline, and part of that discipline is a strong architecture, and part of a good strong architecture is, Stephen, that's right, security. Security controls.
I think I'm going to be good at these questions.
Awesome. So when I think about security design, let me give you an example. Suppose we're doing, we want to save a variable that's tracking how many times the user has failed to log in successfully. So if they exceed some threshold, we'll lock the account. Now, this isn't a perfect control, it's just an example. So if I want to implement that, I have to save an integer of current failed number of login attempts for that user. Where do I stick that variable?
I know. In the browser cookies.
Fail. So do I put it in the request, in a browser cookie, or a hidden variable? I've seen that before. And as the attacker, we can change that all day. Do I put it in the session, or do I put it in the database? A lot of people will say you put that variable in the session, or I can just drop the cookie and get a new session every time. So if I want to track the number of failed login attempts per user, that's got to be in the database,
So it has to
unique
be
for every
persistent.
user. Yeah, it's got to be persistent.
Yeah.
And so, as a developer, though, I can stick it in the session, and it's going to work.
Wait, hold on. Pop the mic. We're running out of battery. Now we're good.
All right.
All right, how's that for agile presentation?
Perfect. So as a developer, I can take that variable, failed number of login attempts, and I can put it in the session, and it will appear to work all day long. And even QA testing it, it will appear to work in some scenario. So,
but very easy for an attacker to write an automated application, bypasses it, just continually spams with new passwords till they crack it.
Exactly, Steve. So we want to, as much as we can in design, we want to specify some of these design patterns and keep security in mind when we do it.
Yeah.
That's a very simplistic example. Now, what should, and design covers threat modeling, business logic design, and much, much more than just that small example. But what should fall out of a good design process is a series of requirements. Number 2 in our proactive approaches to secure coding. We want to have good requirements so we can prescriptively tell developers not just how the application should work, but what the security properties of that software should be. Hey developers, who out here, I'm just curious, who out here happens to be a Java developer? Anyone? Yeah. So how many times in your career have you been given a series of clear requirements that define how you code that application securely? You have 0. Okay, you went, yeah, right. But we can do this, and we should do this. Here's an example. Out of a good design process, we should have at least 2 major kinds of requirements. The first are functional security requirements. Like if I'm going to do the forgot password workflow, or change password feature, or the edit user feature, there's going to be security properties in all of those functionality, and that's stuff that a QA person can test easily. Another class of security requirements are non-functional requirements. These are things that are not visible, that a normal QA tester can't easily test, and we usually need security specialists to test it. And an example of that would be like a non-functional requirement. All your queries should be parameterized. Your password storage system should use an HMAC or an adaptive hash. And then we have business logic requirements, and now more important than ever, well, it's really important in Europe, but it's not so important in the US, privacy requirements. Yeah, so this is what should fall out of a good design process, is a list of requirements that I can give to a developer. Now, most people say, you must write secure code, and as a developer, you're like, well, how do you do that? And well, I don't know, just go figure it out. That's a path to failure. So we should spec out what the security properties of software should be. This is ideal, but you end up saving a lot of money and resources.
So if you're getting your requirements from a product manager, a product owner, or somebody who's driving what your application should be like, how do you educate them on what they should be giving you for security requirements?
If you have a product manager who's driving technical requirements that really knows nothing about security, there's a lot of frozen lakes in Sweden we can drop them into. It's going to lead to disaster. So it's fundamental that you have security buy-in from the C-level down. And especially when you're talking about product managers, technical project managers who are driving developers' time, if you don't budget security into that, it's a path to failure. And again, if you look back 5 years, security requirements didn't matter so much. The whole world has changed. This is the golden era of hacking.
Yeah.
Security hacking, not just code hacking.
We wear white hats on this show.
Right on, right. I'm with you. I'm with you there. So yeah, that's the next thing, is good, prescriptive, functional, non-functional, business logic, and privacy-centric security requirements. Let's go to the next one. You ready?
Yeah, ready.
So number 3, Now we're getting a little bit more technical. We want to leverage the security features of our frameworks and good security libraries. If we find ourselves building our own custom input validation layer, if we find ourselves building our own custom output encoding library, if we're doing password storage from scratch every time we write code, it's a failure. So we want to have good, reusable, this is just normal OO, normal good development.
Yeah, but it matters more for security because those are things which, if you're using an open source library, if it's getting people reviewing the code, if people are contributing security patches, then you don't have to do that yourself.
Exactly, and it's difficult in the Java ecosystem to find good security libraries, I think. And so some of the ones that I work with at the OWASP Foundation is the OWASP Java Encoder project, the OWASP HTML Sanitizer project, the Apache Shiro is a good access control project. Google has a project called Keyzar, which is just one of the best crypto libraries in the Java ecosystem. And by leveraging these very well designed and well thought out and well maintained security libraries, it enables us to build secure software more efficiently and with long-term maintenance of those controls in mind as well.
Cool.
Let's move on. What's number 4? Let's charge on. And this is a giant topic: identity and authentication. This is something that individual developers doing day-to-day work should not be doing. There should be some kind of standardized layer standardized components that is custom to our business that we can roll out.
This is a big problem for the Internet of Things because you have all these devices talking to back-end services, and they really don't know your identity. They're exposed to man-in-the-middle attacks, all sorts of ways you can exploit these.
Yeah, we'll just use the Facebook login button on everything and you're good to go. I am kidding, by the way. No offense to Facebook, but it's a lot of the trends of consumer software is to use federated identity, the Facebook, Twitter, and other login systems. And for high security software, I'm not a fan. It's not the right way to go.
Yeah.
And so, so let's leverage what frameworks we can. Let's audit them well. Let's use them properly. It's gonna.
Hold on. All right, so we are on battery set 3.
So some things I talk about when thinking about identity is when to do re-authentication.
Yeah.
Forgot password workflow, which I think a lot of folks get wrong. No password reset link, let's do it multi-factor style. Or things like how to store a password in proper form. And then we can get into OAuth and federation, SAML, and it's a very broad topic that we can spend all day talking about at least.
Cool. What's number 5? Are we to 5 now?
Access control.
Access control.
Authorization, access control. This is a layer that is probably one of the most difficult layers, I think, in complex software because there's no good standard on doing access control. And most languages, and I'm not just pointing at Java, I'm talking about the entire ecosystem of software engineering.
Yeah, no, it's not built into the languages and the frameworks, and attempts to kind of glue it on top of your application ultimately are error prone.
I agree, and a lot of the languages now standardize on RBAC, role-based access control, which is dead, which is a horrific pattern. I don't believe in it. And I don't want to attack Java at all or any language. It's what we depended on for many years.
Yeah.
In the era of multi-tenancy and cloud-based computing and more advanced web-centric software, the security benefits of role-based access control fade. So we want to move to more of a capabilities-based access control system, or what NIST just standardized, ABAC, activity-based access control, where we're no longer coding to the user property. Like, we're no longer saying things like, if the user is an admin, or if the user is a manager, or if the user is this, and we hard code that everywhere, that's a path to failure. I like it better if the user is allowed to conduct this activity. Now we're checking on what the user is doing and what data they're accessing, not who they are.
Yep.
We need to shift our whole thinking into these more modern access control models. I think Apache Shiro in the Java ecosystem is probably one of the earlier projects to really approach capability type access control very well. Now there's a critique there's a critique of this kind of thinking in that when you're doing role-based access control, you can just slap roles in from day one and make it work. But when you're doing capabilities and more data contextual access control systems like I'm describing, there's a lot more setup before it starts working. So a friend of mine here, one of the speakers who was talking about IDE optimization, she's saying that using Apache Shiro to build access control into an existing system and augmenting it was incredibly painful, mapping Shiro to her database. But that's always going to be difficult when building a good data contextual access control system, but we need to do it. The wins will come out later.
Got it.
Let's charge on. Next.
6.
This is my personal favorite security control. Do you have a security control that's your favorite, by the way?
No, I don't.
You don't have a favorite security control, Stephen?
Nope.
I think that's a part of your life that's missing something fundamental. We're going to work on that with you, Stephen. Let me think. What kind of security control guy do you think Stephen is? Let me think about this. He's kind of man of peace. He's kind of reserved. What would be a good security control for Stephen? I think encryption in transit, good SSL. I think that's going to be your favorite security control.
Yeah, no, that is my favorite.
Oh, good man.
That's my new favorite.
Good man. Good man. So number 6. Query parameterization. Now we're jumping from high-level design ideas to a very specific control. Steve, why is query parameterization such a fundamental control for secure software? Phone a friend? Let's phone a friend. So I'll be your friend. Let's phone. Hi, Steve. Good question. Steve, that's a good question. First of all, query parameterization is to stop SQL injection. Query parameterization, using the prepared statement class in Java, it's the only way we can absolutely stop SQL injection attacks that modify database queries in our applications. It's a very...
So I just phoned my friend in Hawaii, Jim.
Right on.
And it's the only way you can stop SQL injection attacks is to use query parameterization.
Steve, that is exactly correct.
Thanks.
That is exactly correct.
Well, I mean, you got to thank my friend Jim. He's awesome.
Well, I know you're kind of you're a client-side guy. I've seen your book on FX, and I see you're on the client. I'm kind of more the back-end server guy, which is why the quality of the look and feel of my slides are so awful. So it's all good. So number 6, query parameterization. It's a very narrow control because SQL injection is such a prolific problem. It's an easy way to do massive damage, and so that's one of my favorite controls: query parameterization. So next, we'll talk about input validation. This is, almost every Java framework has a good input validation library in it. Struts, Spring, they all have their unique input validation layers. Just use them for all variables.
On input validation, I like to put it on the client, but then leave it off on the server.
You're excused. You can go now. I'll just take your headset. No, he's kidding. No, but actually, client-side input validation is really good for intrusion detection. If you have really strong server-side validation and strong client-side validation with the same validation rules, when people start evading your client-side validation and start breaking validation rules on the server,
you know they're not going through the official clients.
If the design is built correctly, one mistake in validation, it's lock their account. Especially when you're doing FX to web service type programming, they don't have a choice in client. They're using your client, and if it's built correctly, the only way to evade your input validation in the client is if they're man-in-the-milling you or intercepting the request or doing an evil twin attack where they use a modified version of your client to use the same web services. So input validation on the client is good IDS, intrusion prevention. And again, if you do it right, you can have a very low tolerance of server-side validation rules. One mistake, only a non-standard user can do that.
So I think Jim and I both have a new skill, and that is swapping batteries into headsets. Hold it in for a second. You should be good.
Check.
Go.
It's all good?
Yeah.
Check. There we go. So yeah, so client-side validation in sync with server-side validation. You can be very low tolerant of server-side validation errors, and you get some intrusion detection. Next, another cool part of input validation that's non-standard is when you're dealing with untrusted HTML. So if someone's using like a tiny MCE or CK editor where they submit untrusted markup to your server, we need specialized validation, and there's some OWASP projects that do that. One of them is the OWASP Anti-SAMI project from Arshinder Birshiagi. Another one is the OWASP HTML Java Sanitizer project from Michael Samuel. These are specialized libraries to set policies around what HTML you're going to accept.
Cool.
That's charge. Next is, what do we have next here? Encoding. This is like my second favorite control. And this is when you're doing escaping in the user interface primarily to stop cross-site scripting. So one of the OWASP projects there is the OWASP Java Encoder project written by PhD candidate student Jeff Ikonowski. And this is a great library, the OWASP Java Encoder. What it lacks in good marketing in the name, it makes up for in quality and performance. This is a library you can use in the user interface to escape untrusted data to eliminate any potential JavaScript that might be in untrusted data. This is what cross-site scripting is. We want to do escaping in the client to defend from that risk. Next, data protection and privacy. This is like you doing cryptographic storage and SSL cryptographic transit properly. For
encrypting data at rest.
Yeah, for encrypting data at rest, don't do your own crypto. You're gonna get it wrong. You need to do AES in the proper mode with the proper padding and proper IV management and proper key management and proper cryptographic isolation. It's a challenge for even top-tier experts. So I use a library called the Google Keysar project, an open source project that's really one of the best crypto libraries of any language, frankly. And so another open source Java project. And not just using Keysar, you want to make sure you isolate your crypto into isolated services. That's probably one of the more important parts of good design. And then we have SSL. There's a great website from Ivan Ristic called SSL Labs. It's a way to quickly verify how good your SSL configuration is. And it's really tricky to get that right and very important to get that right. So I think we're coming to the end here. I know it doesn't sound exciting, but to me, good logging is very exciting. Do you agree with that?
Yes, yes.
I heard it, but I didn't feel it. But that's okay, I can work through that.
Yeah, so in the back of my mind, I was thinking good logging, and I was thinking, there's a good area for improvement for our Beyond Lambdas panel.
Yeah. There's also a song from Yore that talks about the joy of proper logging in programming.
Oh.
Ever Ren and Stimpy?
Yeah.
Have you ever watched Ren and Stimpy?
Yeah, yeah.
Do you remember, you know what song I'm going to talk about?
No, I don't.
The log song?
Are you going to hum it for me?
It's log, it's fun, it's heavy, it's wood. It's log, it's better than bad, it's good.
That was really good.
Thank you, I appreciate it. That's from Ren and Stimpy.
It's coming back now.
It's the
Thank
log
you.
song. We'll do more of that later after we had a few beers. So.
Sounds good.
So, but the importance of logging is it's to handle incidents when things go wrong. We want to build our software to prepare for failure. We want error handling, proper exception handling to make sure we're not leaking data and handling failures in software properly. And also intrusion detection. A lot of the products we normally buy for intrusion detection at the network layer don't translate well to the application layer.
Yep.
So we want to embed intrusion detection into our software. Another OWASP project that works with this is a project from John Melton and Michael Coates called the OWASP App Sensor project. That lets you, it's a Java project that lets you embed security-centric sensor points deep in your code. So when things go wrong, you can set a bogey for users and take a variety of different actions based on the severity of what they're doing deep in your software.
Cool.
And with that, we just went through 10. So that's like my first pass, the initial awareness when talking to folks about secure coding.
So if folks wanted to find out more about the secure practices and OOPS, where would they go?
Well, I just talked about the OWASP Proactive Control Project. So go Google or Bing or Alta Vista, the OWASP Proactive. I just said Alta Vista. Is that still even like up and running? Or
I haven't hit it in enough years. I cannot answer that question.
It's showing my gray hairs there. It's the OWASP Proactive Controls Project, the OWASP HTML Sanitizer Project, the OWASP Java Encoder Project, the Apache Shiro Project, the Google Keysar Project. These are a series of Java libraries that can help you as a Java developer write more secure software.
Cool. Thanks very much, Jim.
Pleasure to be here. Thank you, Steve.
Okay.